All right, so here's number 23. Once again, we're just breaking the logarithmic expressions apart using the power product and quotient rules. So we see we have log base 2 of x to the ninth power over x minus 5. We want to start out by changing the quotient to subtraction using the quotient rule. So we'll have log base 2 of x to the ninth, which was our numerator, minus log base 2 of x minus 5, which was our denominator. Now we want to use the power rule to simplify this expression. Over here on the left, we'll bring this exponent down to being the coefficient. Our final answer is 9 log base 2 of x minus log base 2 of x minus 5. For number 24, so now it is starting to get thick. We want to make sure that we are keeping track of everything. And just to give you guys a visual aid, I used colors to show what was the numerator here, what's the denominator, because first we need to change the division to subtraction using the quotient rule. So we have, we're going to end up with log of x times x plus 7. All of this was our numerator, so all of this is now going to be the first part of the expression, and it's going to be minus log of x plus 8 raised to the fifth power, which was our denominator. So now we're going to use the product rule on our expression on the left for the part that's being multiplied, and over here we're going to be using the power rule for this expression that has this exponent on its argument. So we'll change this to log of x plus log of x plus 7, and it'll be minus 5 log of x plus 8. So this 5 came down in front. We changed this x times x plus 7 to an addition of logarithmic expressions. Number 25, they start out with the natural log of this expression here. So first we want to use the power rule because this entire expression is all raised to the 1/2 power. So we want to bring a 1/2 down in front and then begin to work on the expression that is on the inside now. So we're going to use the quotient rule of this. So we'll take the numerator here and separate it from the denominator using subtraction. And we see we have x squared minus x minus 2. We have this quadratic expression here that can be factored. So we'll change this x squared minus x minus 2 and factor it, and it becomes x minus 2 and x plus 2. Sorry, this should be x minus 2 and x plus 1 actually. So let's go ahead and make that correction. X minus 2, x plus 1. Let's see, we multiply, we get negative 2, negative 1x. Okay, so now it has been corrected. I apologize for that. So now we have 1/2 ln x minus 2 times x plus 1, and all of this logarithmic expression is being, you're subtracting away from it the ln of the denominator, which was x plus 5 raised to the third power. So now we're going to use the product rule over here on the part that's being multiplied, and we're going to use the power rule on this part where you have an exponent attached to the argument here. So the 3 comes down in front, and we separate this expression using addition, keeping in mind that we will have our 1/2 on the outside of everything over here from the original part of the problem. So you keep that 1/2 and just keep bringing it down, and remember that it's going to be distributed across whatever you're left with. So we keep a parentheses outside of everything. So we change that to addition, and we have subtraction here. So I tried it in Math Excel. They will take it both ways. You can either distribute this 1/2 into here, which I have done here at the bottom, or you can leave the 1/2 on the outside. Just be careful when you distribute it down to this part on the end that it becomes 3 over 2 because you already have a coefficient that's here. So either way will work for your final answer. Now for number 26, we have 4 log base 5 of u plus 2 log base 5 of v. We want to use the power rule first because now we are combining this into a single logarithmic expression. Now we want to condense it. It's starting out and expand it form, so now we want to condense it back together. So first we're going to use the power rule to bring this 4 to being the exponent up here on this u, and we're going to bring this 2 from being the coefficient, and we'll change it into the exponent on the v. And then from here we have addition of logarithms with the same basis, so we can now condense this using the product rule. So we'll change that to log base 5 of the quantity u to the 4th power times v to the 2nd power. For number 27, we have we want to write this expression as a single logarithm again. So we want to take this and condense it together as much as we can. Now remember, when we have the square root of something, that we can rewrite it as that raised to the 1/2 power. So we'll take the square root of x, we'll write it as x to the 1/2. And now because we have subtraction, we're going to use the quotient rule. So we'll have log base 5 of x raised to the 1/2 power over x raised to the 9th power. And then here we can apply the exponent rules for quotients. It says when you divide bases, you can subtract the exponents when the bases are the same. So we're going to be doing 1/2 minus 9, and that will leave us with negative 17 halves. So we'll have log base 5 of x raised to the negative 17 halves. And then now we can apply the power rule. We can take this exponent and move it down in front. So we'll have negative 17 halves times log base 5 of x as our final answer. Now for number 28, again, we want to condense it into an expression with just one logarithm. So we have the same basis here, and we see that we are going to end up subtracting. But first, we want to use the power rule to take this 6 and attach it to our argument as the exponent up here. So the 6 goes up here, and then we apply the quotient rule to change this into division. So we'll have x squared minus 25 as our numerator. The x plus 5, which will now be raised to the 6th power, will be our denominator. So we can factor our numerator up here. We can factor that, and that will become x minus 5 times x plus 5. So we factor our numerator here. So now we see we have x plus 5 times x minus 5 over x plus 5 raised to the 6th power. So we can reduce one of these x plus 5s with one of the x plus 5s that we have down here. Down here we have 6 of them. So this one will cancel. We'll take away one of these. So our final answer will be log base 4 of x minus 5 over x plus 5 all raised to the 5th power. So now for number 29, again, we want to rewrite it to basically condensing it back together. So first we want to apply the power rule. We'll take this 2 and bring it up here and attach it to our argument as the exponent. And then over here on this side, we have 1/7, and we'll take this and we'll make this our exponent over here on the right side. So now we'll have 6x to the 9th, and this will all be squared. So we can simplify this exponent here, and we can make this become 36 because we have 6 squared, which is 36. And here we're going to multiply the exponents. X to the 9th squared will become x to the 18th. And then over here on the right side, we had a rational exponent, which remember becomes a radical now. So we have log base a of the 7th root of 7x plus 15. And then finally, we have subtraction, so we can use the quotient rule to combine this into one log expression. And now remember the part that precedes the subtraction sign, that becomes the numerator. And then the part that's being subtracted away, that becomes our denominator. Number 30 says write the expression as a single logarithm. Same situation here. First, we want to take our coefficients and make them the exponents using the power rule. Notice that we have two things being subtracted here. We're subtracting the log 7 x minus 6, and we are subtracting the log 7 x minus 7. So that, because that's all being subtracted, those will both go into the denominator once we change it into a quotient. So the log 7 x plus 7, that x plus 7 squared is the numerator. What's being subtracted away from it all goes to being the denominator here. So now we see with problem number 31, we get back into the multi-part the problems with multiple parts. So they give us three different functions, and they ask us to apply some rules, some transformations to them. So we need to evaluate those. For part A, they say what is f of g of x. So we're going to take g of x and plug that into f of x. So we're taking e to the 5x power and we're plugging that in for x in the f of x function. So our final answer for this part is going to be ln of e raised to the 5x power. And then to simplify it here, we're going to use the power rule. We'll bring the 5x down. And remember, we have same base argument situation. So we're finally going to be left with 5x for part A. So when it asks us what is the domain of this function, remember now the domain comes from the part when we first made the substitution, when we first plugged in e to the 5x. And the domain of this, well, we can plug in anything for x. The domain of the exponential function is all real numbers. And then for our final simplified part of the problem, the domain here is also all real numbers. This is just a linear function. So this function, the domain goes from negative infinity to positive infinity. Now for part B, we're switching them around. We're plugging f of x into g of x. So we're taking this ln x and we're going to plug it in for x here into the g of x function. So we'll have e to the 5 ln x here. So now we have e to the ln x to the 5th power. Remember, we have inverses here. This e raised to the log base e will undo each other and would simply be left with x to the 5th power. So now the domain of our final simplified form of the function is going to be all real numbers. However, going back to when we first substituted f of x into the function, the domain of ln x here is going to be x is greater than 0. So we have to combine, we have to take those two domains together. So it can't just be all real numbers. It's limited from when we first made the substitution to x only being greater than 0. So our final domain is going to be from 0 to infinity. Now for part C, we have f of g of x. For C is asking us to evaluate f of g of 3. Remember now we already for part A evaluated f of g of x, which is just 5x. So now all we need to do is plug 3 into 5x. So we have 5 times 3, which is 15. Again, we had already found f of g of x in part A to be 5x. So when we're doing f of g of 3, we can just plug 3 into the 5x. So that is how we end up with 15. Part D says find f of h of x. For h of x, they gave us x to the 4th power, so we're plugging x to the 4th power into f of x here. So now we're going to have ln of x to the 4th power. So you could use the power rule here. You would have 4 times ln x, or you can leave it as ln x to the 4th power. So now for x to the 4th power, when we first plugged that in, that domain was all real numbers. However, remember now we can't have x being 0 here because we can't have ln of 0. So our domain restriction is going to exclude 0. So if we write that in interval notation, that will go from negative infinity to 0, union from 0 to positive infinity. All right, and then finally for part E, it's asking us to plug e into f of h of x. So we just found f of h of x here. We got that to be ln of x to the 4th power. So now we're just plugging in e for x into that function. So f of h of e is going to be ln e raised to the 4th power. We can use the power rule now. We'll have 4 ln e And that simply equals 4 times 1, which is 4. And we are done.